Okay, so we're back in the Neo4j browser. And if you're starting from where you left off, you probably already have a couple of windows here on the right-hand side. Now in Neo4j, these are referred to as frames, and we can cross out any of our frame results using the cross on the right-hand side here. In the main query bar, we can type :clear and use Control-Enter to run that, and it clears all of those frames. So Control-Enter is our shortcut for that play key, and the :clear clears all of those frames. In the previous video, we used this button over here to return a random sample of nodes from our graph. Now we're going to try and be a bit more specific, and as we do that, I'll talk you through the syntax of Cypher. Similar to a from statement in SQL, where we're kind of defining the scope of where we want the data to come from. In Cypher, we're writing a match statement. So we're writing match, and we follow that with a pair of brackets, and those brackets represent a node. Inside the brackets, we can give the nodes an alias, so we're just going to use the letter N. Since we haven't used any conditional logic, what we're saying here is the scope of the data we want to work with is simply all nodes. In SQL, while the from statement defines the scope of data you want to work with, the select statement defines what you want to return. Here, match defines the scope, and return defines what we want to display in our results. And so we're saying define the scope as all the nodes and return those nodes, and we're referring just to the alias this time. Now the first time I do this, I'm going to run this without a limit statement, just so you can see what happens. I press Control-Enter. Because I haven't limited it, I get a crazy number of results. I get this warning on the right-hand side telling me that not all the nodes have been displayed. We've actually got 28,000 of them in this graph, and only 300 are being displayed. Now for what we're doing at the moment, we don't need to see 300. So I'm going to modify that last statement. I'm going to press Control-Up to bring the previous query back into the main bar at the top, and we're going to use a limit statement to limit our results to 25 nodes. To take a step towards a more specific query, I'm going to bring that last one up again using Control-Up. And inside the node pair of brackets, I'm going to define which label of node we want to return. And I'm going to return movies. So what we're now saying is define the scope of data that we're working with as all nodes, hence the brackets. Give those nodes an alias of N, and restrict the scope to nodes of type movie. From that scope, return the nodes, and limit the results to 25. So this time, we only get movie nodes in our results. Supposing we do the same again, but instead of 25 movie nodes, we return 25 actor nodes. Let's see what happens. See, we run that query, and this time we're actually seeing nodes which appear to have different labels. So we asked for actors, but we seem to be returning actors, persons, and directors. So let's see what's going on here. Zoom in to the graph and just hover over one of those nodes. When we do that, the node properties on the right-hand side tells us which labels apply to the selected node. So the one we're hovering over is not only an actor, but they're a director and a person also. So it just happens that the one color that's being displayed is director. If I hover over this one instead, this one is actor and person. If we hover over a few more, we can see that regardless of what color is returned, each node is at the very least meeting the condition that they are an actor. So what we're seeing here is an example where nodes can have more than one label. They can be more than one type at the same time. Looking down through the result frames, we can see that the previous ones had not only nodes but relationships, and the last two we've created only have nodes. So why is that? What Neo4j generally does is if two nodes are being returned as part of the results and they happen to have a direct relationship between them, that relationship will appear. But in this case, we've returned a list of movies, and there's no direct relationship between two movies. They may be indirectly connected by an actor who worked on both movies. But there is no explicit link between the two movies, so that's the reason we're not seeing them, and the same in this actor scenario. Let's try this time to define some of those relationships that we want to see. We'll write a new query. This time I'm going to match, and I want to find all movie nodes. From this point forward in the course, what I'll try to do is use an alias which matches roughly with the node label that I'm using. And this will help keep things simple as our queries get more complicated. So we're using an alias of M for these nodes, and I want only nodes that are movies. I want the scope of this query to be movies that have a relationship to another type of node. And so this time I'm going to use person. So we're saying define the scope as all movie nodes which have a relationship with person nodes. I've used P as the alias for person, and my relationship is simply written as those two dashes. So from that scope of data, I want to return both the movies, comma, and the people, person. And I want to limit the results to 25. Now I haven't explicitly said, show me the relationships, but because there does exist a direct relationship between the movies and the people, now I start to see them appear. We see examples here of people that acted in movies, and we see examples where people performed more than one role on a movie. So Harold Lloyd both directed and acted in this movie. So you can start to imagine queries where we can say, well, show me all actors that both directed and acted in the same movie. In the same way that we limited the scope of the nodes we wanted to return, we can do the same thing with the relationship. So in the middle of those two dashes, I'm going to use a pair of square brackets to add some details about this relationship. I'm going to give it the alias of R. To define a label, I use colon. And you can see the suggestion list. I'm going to go acted in. So now our scope is show me movie nodes that are related by the acted in type to a person and return both types of nodes. This time when we explore the graph, we can see we're only returning acted in relationships. We no longer have any director relationships. Let's take a look at relationship directionality. Colon, clear, and let's remove everything we've done so far. We start with our match statement, and I want to define the scope as users who've rated something. So we'll use the alias of u, and using the colon will restrict that to all user nodes. We want those users to have rated something, so they have a relationship. Inside the square brackets of the relationship, we can use the alias r, colon, and we want rated. Finally, we want to return the nodes that those users have rated. So I'm simply going to define the rated nodes with the alias of m, which implies movie, but I'm not actually going to restrict the node type to movie, as I probably don't need to, as the only thing users are likely to rate are movies. With that scope defined, let's return u and m, limit 25. We have a few results there, and if we zoom in, we can see that these relationships actually have a direction to them. This user rated this movie. If we were interested in searching for only that direction of relationship, we could define that up here in our query. We could add the triangular brackets to the end of the relationship to show that we want the rated relationship to go in that direction, users that rated movies. We run that and we get the same result. But if we change that around and place the direction arrow on the other end and run the query, we get no results. And that makes sense because movies don't rate users. Users rate movies. So we can start to see how the directionality of our relationships is important to our queries. So far, we've known exactly what we're looking for, and we've been making a few assumptions along the way, like we assumed that users only rated movies, but perhaps users can rate actors as well. So how do we really know what relationships exist in the database? To find out, we can view the database schema. We use the call statement db.schema.visualization. And when we run that, we can see all of the node types that exist in our database, as well as the relationship types, and between which types of nodes they exist. If all of your captions aren't showing, remember you can change those on the right-hand side over here. We can see that people either directed or acted in a movie. And since we know that some of the nodes in our database can be both persons and directors or persons and actors, it makes sense that those nodes can also have the same relationships. Movies also belong in genres, and users rated movies as we expected. And all of these relationships have a directionality to them. Movies don't direct people, and genres are not in movies. And so using this database schema, we can quickly see what data might be available for us to query. In this video, we're going to talk about conditional statements. To an extent, we've already covered some of this. If you think about this match statement that we had, where we found user nodes that had rated something, we've explicitly said that this first node should only return users, and the relationship should always be rated. So we've already defined some conditions like that for the labels associated with the nodes and relationships. But we can go further than that, and we can write conditions on the properties of each of these things. If I click on a film, in the right-hand side window, I can see the properties of that movie. It extends way beyond just the title and includes IMDb ratings, the number of votes, the language, a short description, and all sorts of other information. So let's have a go at creating some more complex conditional statements. I'd like to know all the people, so actors and directors, who were associated with the movie Top Gun. So let's define that as our scope. Match. And the first node I want to be a movie. We can restrict the label to movie nodes, and in addition, I want to say that the title should be Top Gun. To define a property condition, we do it in these curly brackets. We write the property name, title, colon, and then in text, Top Gun. Before we add people into this, I'm just going to return limit 25. And that's just to make sure that we've got the syntax right. So we've got the movie Top Gun. Now let's amend that last query to return the associated people as well. So Control Up brings that query back to the top. And within my match statement, I want to expand the scope to include relationships to a second type of node, which we're going to restrict to persons. So that now says, find all movie nodes that have the title Top Gun, and in addition, expand that scope to all the persons associated with that movie. So like we said before, this is equivalent to that from statement in SQL. The return statement is like select. So if I run this statement here, I'm still only going to get the Top Gun node being returned. And that's because although the scope is defined as Top Gun and all the associated persons, I'm only returning the movie node. So I have to add in comma P to return the people as well. There's actually a second way that we can write this query using a where statement that might be more familiar to those of you using SQL. In my opinion, the where statement does make things a little simpler when queries get more complex. So this time we're going to write match movie nodes that have a relationship with person. I'm going to use Shift Enter to start a new line in this query just to keep things tidy. This time we use a where statement, and we want the scope to be restricted to where m.title equals Top Gun. So we're using a dot there to reference a property of an aliased item. So movie.title. We've set the condition. So let's return m and p limit 25. And we get the same results of defining conditions for our queries. Let's explore these conditional statements in a bit more detail. So far we've looked at how to restrict a node's type to a particular label, and we've introduced this where statement where we've used the dot to specify a condition on a particular property. I've written another example here. I'm matching all movie nodes where m.year equals 1986 and return those nodes. If you're using a slightly smaller version of the database or a different one, you may have to change this property. So that's about as simple as we can make that where statement, and we've returned all the movies from 1986. Now we can use an or statement or an and statement within our where clause. So I could say where movie.year equals 1986 or movie.year equals 1987 and effectively return both. And you can see there's far more nodes returns there than in the previous, 280 versus 135. Instead of defining a long list of potential OR scenarios, we can use the in syntax from SQL to provide a list of possible values. So in square brackets here, I'm going to say 1986, comma 1987. So return the movies where the year is in this list. And we should get the same results. There we go, 280 nodes. We can use conditions like greater than, less than, and obviously the equals to. So let's say where m.year is greater than 1986, return m, and I'm going to limit the results to 25. So we've got all of the same conditions that you're used to applying in your queries, and we can apply those within that where clause. I provided a full list in the course presentation and put a link to the Neo4j documentation where you'll find more examples. Now, as we work towards our end of chapter exercise where we're going to try and provide some movie recommendations, the where clause becomes more and more important. It gives us that ability to be specific with our queries, and it's going to help us when we answer any specific business scenario. In the last couple of videos, we've looked at how to apply conditional statements to properties. We can do that with either nodes or relationships. But I just wanted to circle back to the labels that we've been using to show how we can apply or and conditions when using labels. So far we've used a syntax like match nodes that are actors, return those nodes, and limit 25. I know I've used n there for actor, but you'll see why in a second. Supposing we wanted to return more specifically, not just actor nodes, but actor nodes that are also directors. So the label condition there is actor and director. What we can do is follow up the word actor by another colon, and this time apply director. So this is saying set the scope of my query to all nodes that are both actors and directors. This is an and condition, and return those nodes. When we return the results, we hover on those, and we can see that every node is both an actor and a director. You can see that the reason I used n for my node now is that I knew I was going to have more than one label type here, and so I just kept it as a generic n. We can switch around the syntax slightly to make use of the where statement. So match nodes where node colon actor, and colon is used because we're defining a label, and node colon director. Return the nodes limit 25. Again, we get the same results. We can replace and with or if that's our desired condition, and we can even shorten this slightly by using the same syntax as before and following one node alias by two labels. Either way, that's going to give us the same results. The last example I want to give you is just looking at labels on relationships instead. So this time let's match person nodes that have a relationship to movie nodes. And in the relationship, we want to say label must be directed, or using the pipe symbol, label must be acted in. So there we return P and M limit 25. So here we said the scope of our query is people that have relationships with movies, where those relationships are either directed or acted in. Zooming in on our queries, we can see that's exactly what we have. Now notice as well that I didn't give the relationship an alias there, and it's really not a requirement to do so, and that applies to nodes as well. The only time we need an alias is when we need to refer to it later in our query. I don't need to explicitly ask to return the relationships, so I don't really need that alias. We can extend our conditions a little further even by referring to relationships and or patterns within the where statement. So this time I'm going to look for all movie nodes, and I want to match all patterns that have a relationship to user nodes. So these are the ones that are actually rating these movies. Instead of defining which label I want on the relationship here, I could do that within my where statement. So where R colon for a label, and the label I want is capital rated. But I also want a second condition. I want to see only the ratings that are above 3. And since rating is a property of the rated relationship, I want to say and r.rating is greater than 3. Then I can return m and u limit 25. And what we'll see in the result is a selection of users and movies, but the key here is all the relationships are rated, as you would expect, but all of the ratings which appear as properties on those relationships are always greater than 3. Now, as we work towards this basic movie recommendation engine, there are other factors we might want to exclude. At the moment we're returning all rating relationships with a score greater than 3, so we're generally getting the movies that people like. But what if for one user they've explicitly said that they only want to see war movies? Well, we can't get that information from the movie itself, but movies do have a relationship to genre nodes. And so we can build in a relationship to the where clause itself. So we use and. The movie node, which we're referring to with the same alias to make sure it's the same node, has a relationship to, and we can use the genre label, and then we have to provide the genre name. Name is war. So this time we're saying match users that rated movies as a pattern where those ratings are greater than 3 and where those movies have a relationship with the war genre. So this time our results still show us users that rated movies, but those movies all fall within the war genre. And so these kind of restrictions are going to help us as we build our recommendations. Already in this course, I've made a lot of comparisons between Cypher, or CQL, and SQL. And that's purely because I find that it can help us when we think of Cypher with some equivalent statements in SQL. Let's quickly recap the comparisons that we've made so far. We'll do this by summarizing what we see in SQL on the left and what we see in Cypher on the right. In SQL, we write our statements in a certain order, but they're executed in a different order. So the order of writing our queries always starts with select. Then we have from, where, group by, having, and order by, and they're always written in that order. But the order that they're actually executed, which we call the order of operation, is slightly different. The key difference being that the select statement actually happens later on. In terms of equivalent statements in Cypher, the from statement is equivalent to the match statement. What they're both doing is really defining what is the scope and therefore the source of data we're working with. The from statement in SQL defines the primary table that we want to draw information from, and we can even use a join to add more data to that. In a similar way, the match statement in Cypher defines the scope as all nodes and relationships that match a particular pattern. The where clause is simply the where clause in Cypher, and both of those are asking what filters do you want to apply to the source data. In SQL, those conditions are applied to column values or attributes, but in Cypher, those where conditions can be applied to labels or properties. Once we've created our query, the select clause in SQL defines which columns or which aggregations we want to return, and so the Cypher equivalent is simply return. What this is saying is what information do you want to return from the query. One more that we haven't yet seen is the order by statement, which is equivalent to order by in Cypher, and all that's saying is in what order do you want to return the final rows of the query. At the moment we've been returning results in graphical form, not in tabular form, so we haven't really needed the order by statement, but you'll see it shortly. The group by and having will come on to later on, as they are slightly more complex. Hopefully this framework gives you a good way to conceptualize the difference in queries between the two languages. Alright, now that you know a little bit about how to explore this graph, I've got a few questions for you to firstly help you start exploring, but secondly, I want to start to get you thinking about this recommendations engine that we're going to work towards. Question 1. Using the database schema, count visually how many unique relationship types exist in the database. Question 2. Find 25 examples of users that rated movies. These are the users that are going to help us collaboratively filter our recommendations later on. Question 3. How many properties exist on the rated relationship? And finally, this one's a bit more challenging, but you should be able to do it with the knowledge you've got so far. Find some examples of movies that belong in the thriller genre. Again, this is the kind of information we'll be able to use in our recommendations engine. Have a go at these questions, and we'll recap in the next video. Let's take a look at these questions. Using the database schema, count visually how many unique relationship types exist in the database. So for this, we can use our call statement, db.schema, visualization, return that result, and we can count 4 unique relationship types: acted in, directed, in genre, and rated. I wanted to get you looking at the schema, but in fact you could answer that question by looking on the left-hand side at relationship types and looking at the different labels that exist here. We have 4. Question 2. Find examples of users that rated movies and limit the results to 25 nodes. So for this, we're going to create a match statement. We want a user node with a relationship to a movie node. We want to return both M and U and limit the results to 25. And we can start to see the relationships where users rated movies. Question 3. How many properties exist on the rated relationship? There were a few different ways to do this one, so let's take a look. The first option was simply to hover over one of the rated relationships from the previous query. And we can see that there are 3 properties: ID, rating, and timestamp. So we know that 3 is the answer. A second way we could have done this was to click on the rated relationship type. All this does is generate an example query with examples of rated in it. And then we can do the same thing, we highlight it and we see 3. The third option would be to create a simple query where we want any node, perhaps with the alias A, that has a relationship of type rated with any other node which will give an alias of B. And we want to return A and B with a limit of 25. So the only thing we've been specific about this time is the relationship type there, and again we can hover and we see 3 properties. So a few different options for you there.